Okay, quickly, let's look at some of these questions that we have here. So these are your JAMB questions. Most of them are likely questions that always come out. The question that you always see in your JAMB are always all right. So the question they give you is always the same thing. Now let's look at question number one. Question number one says, what is the least possible error? Least possible error. Okay, let me use my red here. So what is the least possible error in a rule graduated in centimeter? The word rule, the word least possible error, sorry, least possible error, still is still the same thing as your accuracy. They are asking you about the accuracy. Now this question falls under measurements. It falls under the topic called measurements. Now first thing you will have to know is this: for you to get the accuracy or the least possible error of any measuring instrument, the first thing you need to do is divide the smallest unit of that graduating is of that instrument, divide it by half, like multiply it by half, so you say half times the smallest division, half times the smallest division of that instrument, now from that you now get the accuracy. Now the smallest division of meter rule or rule graduated in centimeter is 0.1. The smallest division is 0.1. So you say 1 over 2 times 0.1, and that is going to give you what? That will exactly give you 0.05. So the answer is going to give you 0.05 cm. So coming to the question, none of the option is the correct option. So the answer is no option. Then question number 2. For question number two says, which of the following effects? So question number two says, which of the following affects the period of a simple pendulum? Remember one thing about simple pendulum. This question falls under simple pendulum, simple harmonic motion. So the topic is under simple harmonic motion, whereby they say that period is equal to 2 pi square root L over G. So you now see that this period is dependent of what you call what now? This L is called your length. Then G is called your acceleration due to gravity. So you see that is what we have now. So now coming to this now, what do we have as option? Option A, we have mass of the pendulum. There's nothing like there's no mass here. Then the next one is length of the pendulum. I've already mentioned the length of the pendulum. Then the next one is acceleration due to gravity. So acceleration due to gravity. So the correct option is going to be the one that has 2 and 3. So 2 and 3, option B is the correct option. Very simple questions. The questions they will ask you are not difficult. Now the next question, question number 3 says that a boy sits in a train moving with uniform speed on a straight track. So he sits on a train with uniform speed. Okay, so what happened to the ball? Then they say that if from his outstretched palm he gently tosses, keyword gently, the keyword here is gently tosses a coin vertically upwards, which means that he did not throw the coin so far. He just threw it gently, so not with. So he just threw the coin gently, so which means that he never threw it to a particular height. So what happened? If this boy, this is the boy, this is the moving vehicle, this is the moving, and the boy is inside this moving vehicle with his arm outstretched palm, yes, according to what they say, and he threw the coin gently upward, vertically upward. What happened? Automatically, the coin will fall back into his arm. It will fall back into his arm. Why? Why is this so? Now, because since the velocity is uniform, like the velocity is uniform, the boy and the car have same velocity. So the train is covering equal distance at equal intervals. So they have same. Okay, the train has what you call uniform speed with the boy. So for that reason, the answer is going to be what? Option D. All right, so let's look at question number 4. The question number 4 says that a boy starts from rest. A boy starts from rest. Question number 4. I always do one thing. Anytime I hear the word rest, anytime I hear the word rest, I will just say u is equal to 0. So I don't need to read other questions. First thing I do is rest, u is equal to 0. That's the first thing I'm going to do. They then say with a uniform acceleration, then a is equals to what? A is equals to 6 meter per second squared. This question falls under motion. Yes, falls under motion, so it's covering motion. Then they now said, what distance does it cover in the 30 seconds? Distance covered in the 30 seconds. That's what they're asking you. So for you to get the distance covered in a particular second, whether they said 4th second, 9th second, 5th second, and so on, the way it is being solved is, if you want to solve this question, you just say, since they mentioned 30 seconds, if you want to get the distance, S, if you are getting S just simply total distance, whether it's not specific. But since they say third distance, what you're going to say is a distance at the second minus, distance at the third second minus distance at the second. So when you subtract the two distance, you'll now get the distance at the third second exactly. So that is how to get about it. So you need to get the distance at the third second, and you also need to get the distance at the second. Then you now know the exact distance that it's covered at the third second. So that is how it's been gotten. Now for you to do that, now what are you going to do? Since you are asked to get this, what are you going to do? First of all, distance at the third second is going to be what? You already know that your u is equal to 0. Your a is equal to 6 meter per second squared. Then the time for the third second will be what? 3. The time for the third second is going to be 3. That time is going to be 3. So for the third second, if you are solving for the third second, so what are you going to use? You look for a formula that contains u, a, t, and s. U, a, t, and s. Look for formula that has under motion, the one that has u, a, t, and s. So what formula has u, a, t, and s? So you look for the one that has u, a, t, and s. So what we're going to do is, when we apply this formula, since we are talking about the third second, we say S3 for the 30 seconds is going to be what? Here is going to be 0 because I already mentioned it's 0 plus what is our A? A is 6 times, and what is T? T is our 30 seconds, which is 3 squared. So we have it as S3 is equals to 6 times 9. And that will be what now? 6 times 9 will automatically give me what now? 27. So I have here to be what? 27. That is 27. Then after that, remember they said I should get the distance at the 30 seconds. So I need to get the distance at the second. So I will still use the same formula, u plus 80 squared. So what I'm going to do is I'll still say the distance at the second to be equal to 0 plus, this time around, what is my A? 6 times, my time this time around will be what? 2 seconds. Remember, my initial time was 3 seconds, so this time around it's going to be 2 seconds. So I have it as distance is going to be what? 6 times 4. And 6 times 4 will give me what now? 6 times 4 will automatically give me, am I correct? Sorry, I made a mistake in the formula. I didn't apply something in the formula. Sorry. The formula is supposed to be ut plus half 80 squared. Sorry, it's supposed to have t half. It's supposed to have 2 over 2 here. So which means that what I have here is I have a here is going to be divided by 2. So if I divide this in by 2, I'm going to have 3. So what I'm going to have here is I'm going to have it as 3 times 9. 3 times 9 is going to give me 27. So from this now, let me correct this formula. I will say divided by 2. Divide by 2 because according to the formula that I have here, I have it as ut, and u is already 0. Since it is 0, 0 times t will give me automatically 0. So it's going to be plus half 80 squared. So what I'm going to have here is I also divide this by 2. So this is going to be by 2, so which is 3. So 3 times 4 will give me what? 12. So for you to get the distance in the third second, you say S3 minus S2, so which is equals 27 minus 12. So 27 minus 12 will automatically give me 15. So that's the answer. The answer is 15 meters. That is how to solve that question. So quick one. So let's look at question number 5. Question number 5, can you give me an idea? Okay, so can you give me an idea of the formula that we're going to likely use on question number 5? So for question number 5, how do we solve this question number 5? First of all, range. So tell me the formula for range, because the question says the range. So can you tell me the formula? Can you recall? Because the essence of this class is, let us see if we can be recalling the formulas that we're supposed to be using to solve questions. So drop the formula for range. The formula for range is what? What is the formula for range? All right. So let me quickly do that. For range is going to give you what? U squared sine 2 theta all over g. So that is your range. So if you are going with this now, this is going to be the formula for your range. So if you look at this now, what is going to be the question? First of all, they said a stone cube is sorry, a stone cube is thrown with velocity u. So a stone cube, so for that of cube, for our cube, they say it is thrown with a velocity u at an angle of 75 degrees. So for our cube, for our RQ, what do you have here now? The range is still your range. Then we have it as sine 2 times the angle that we're having here. What is going to be the angle? The angle that we have for the Q is how many now? 75. All over what? All over G. So this is going to give me what now? I'm going to have it as U squared sine 150 degree all over G. Okay, that is for Q. Then another stone R. For the R, what do you have for the R? For the R, the range is going to be what? The range is going to be U squared sine 2 times. 2 times what? 2 times what do we have here now? 2 times what now? 15 for the second one. So it's going to be 2 times 15. So all over what? All over G. So this is going to give me what? U squared sine 30. All over what? All over G. Then at this point, I can basically tell you that the range of Q is the same thing with the range of R. Now, why did I tell you? Why did I say so? Very simple. If you look at this calculation now, you see that, if you look at this now, you see that sine, did you know that sine 150 and sine theta are the same thing? How did I know? Remember that sine 180 minus theta, according to trigonometry, is something as sine theta. So let's confirm. So if I say sine 180 minus, let's say theta is 150, what is it going to give me? It's going to give me sine 30. It's going to give me sine 30 degree. So automatically, so you are now aware that sine 150 is the same thing as what? Sine 30. So both of them are the same thing. So for that reason, both ranges are the same thing. That's why I concluded this. So the answer to this question is, what's the answer to this question now? The range covered by stones. Okay, they say greater than, yes. So the option is what? Option C. So the correct option to this question is what? Option C. So the same for Q and what? For R. So that is the answer to this question. All right, so let's quickly look at question number 5. Question number 5. So let's quickly look at question number 5. So question number 5, I won't be the one to solve it. I need this class to be a bit interactive. So what we're going to do for me is read the question. If you have an idea of what formula we can use, drop it in the comment section. If you don't, say no, you don't have an idea, so that I will know how to help you. Or somebody say the option, the answer is C. What formula did you make use of? What formula did you make use of? Someone said. So let's quickly look at that. Let's confirm if the answer is C. A man weighing, this is whenever you see something Newton, automatically the way I call it force. So 800 Newton is automatically force. Then he climbs at a height of 15 meters. So we have it as height is equals to height is equal to 15 meter, 15 meter. Then they said and the time is how many? Time is what? 12.5 seconds. Okay, so they now say what is the average power output? Power output is what now? I remember one thing. What will you remember? Remember that power is given as what now? Energy or work over time. That is it. Energy or work over time. And what is the formula now? Power, remember this, the power is given as what? Since we have it as work is something as force times distance over time. This is how I got it. And distance is the same thing as height, so I can still say that force times height over time. So from this now, what is my force? My force is 800 times what is my height? My height is what? 15 all over my time is 12.5. So by the time I multiply this now, what is going to be my final answer now? So I'm going to have it as what? 960 watts. So the final answer is going to be 960 watts as my final answer. And 960 watt is option C. That is correct. Now let's go over to the next question. Next question. Then question number, I don't know, question number whatever, whether number 6. So now look at this question. What is the answer to this question? I believe we've done something like this. We did something like this before we went for a holiday or our break. So what exactly do we have here? This question falls under the moment. So what is going to be the answer? First of all, you need to know that clockwise moment is equal to anti-clockwise moment. So which of them is the anti-clockwise moment? This is anti-clockwise moment. You have to direct it to the turning point, which is the fulcrum. So this is it now. So for our F1, we have F1. And you know that moment, the formula for moment is what? Moment has a formula. The formula for moment is going to be what? Force times distance. Okay, someone said the option is option B. Well, okay, let's confirm if it is option B. Let's work together. So we have it as force times distance. So for this now, so this one is going anti-clockwise. It's going anti-clockwise. Likewise, this one is also going anti-clockwise. Then these two are going clockwise. These two are going clockwise. You know, clockwise this direction. Then this one is also going this direction. But so I don't mind interchanging it. So I can use clockwise is equals to anti-clockwise, or you can say anti-clockwise is equals to clockwise. For learning sake and for some of you not to be confused, let me put it this way. Anti-clockwise is equals to clockwise. And what are my anti-clockwise? My anti-clockwise is sum. It's supposed to be sum. Sum of anti-clockwise is equals to sum of clockwise. Sum. So for the anti-clockwise, I have F1 times what? Times A plus what again do I have now? F2 times B. So look at our F2. Look at the distance. So I'm going to have it as F2 times B is equals, we're done with the anti-clockwise. Let's go back to the clockwise. We have it as F3. This is F3 times the distance. F3 times C plus what again do we have here? F4 times what's D. So when we look at this now, we can combine everything together to have something like we have something like F1A plus F2B. Then we can take all these things the other side. We can move these things to the next side. We can move this to the next side. So it's to give me what now? Minus F3C minus, because this one crossing equality sign will also be minus F4D, all equal to 0, because when you sum up everything, the answer is going to be equal to 0. So the correct option is what? Option D. That is nice. All right, so that is it. Question number, the next question falls under friction. So how do we solve this question? If I am to solve this question, this one falls under friction. So how do I solve this question? Who has an idea of how to solve a question under friction? Okay, so let's look at it. So the question says, in the diagram above, the hanging mass M2 is adjusted until until M1 is on the verge of sliding. M1 will be on the verge of sliding. So until M1 is on the verge of sliding. And this question, since it falls under friction, there's something that you need to know. First of all, they said the body is about to slide. So now look at this now. We are going to have what we call tension here. We're also going to have tension that is pulling this body up. Then we also going to have another one called your frictional force, like this. We have your frictional force this way. Then we're also going to have another one here, which is your weight. Your weight is going to be what now? M1G. Your weight is going to be M1G. Then this is your frictional force. Your frictional force here, I'm going to have it as this M1G. That is what I'm going to have. And the reason why I'm going to have it this way is because coming to the frictional force, what is the formula for frictional force? The formula for frictional force, if you may recall, is given as what? This is going to give you like this, whereby this is coefficient of static friction and the R is known as your normal reaction. So R, and this is your normal reaction, this your R is still the same thing as your weight, which is opposite of weight, and it's still equal to mg. That is still equal to mg. So if you look at it now, you see that from what we are doing now, I just did one thing. What did I do? I say that F is equal to this constant, and what did I call this R? I said that this R is mg, so it's something as mg, and that is why when I came to these points, I wrote it as the constant times your mass times your g, which is something that I derived here as well. I derived it here, so that is why I have it this way. Now the question says we should calculate the coefficient of the static friction. So we need to calculate the coefficient of static friction. So how do I calculate this coefficient of static friction? There's something else I forgot to tell you, and which is you should bear it in mind that for this now, the weight of this one is going to be what? Oh, sorry, this is M2. So this is M2 because this is second mass. So the weight of this one is going to be what? The weight of this one is going to be M1G. Then this place is going to be a normal reaction. Up is going to be a normal reaction. So what are we going to do now? Like I said, that we are going to have two forces. The tension is going to be the force that will tend to pull this body towards this way. That is what we call the tension. Then the force that is going to oppose this body from moving is called the frictional force. Remember that they say that the body is about to move. This body is about to move, but it's yet to move. It is not sliding. Assuming it is sliding, it's quite different. It's another game altogether. So, but since it is not sliding yet, you should bear it in mind that it will have tension on that rope. There's going to be tension on that rope, tension force on that rope. Then we're also going to have, then when this body that is going down, we're going to have weight, and we're going to have tension that is pulling this body up. So this is what you're going to do. What you're going to do is, if I'm to solve this question, I've already said it now. The force that we have here is opposite to this our tension. So for the first one that we have here now, for the first area that we have here, I can say that my tension, which is opposite to my friction, this tension is opposite to my frictional force. And remember that I told you that your frictional force is the same thing as what we call this, something like this. So for that reason, I can say that my tension is equal to your constant times your R, and whereby this is the same thing as what your tension is equal to this M1G. I've already mentioned this initially. I've said it initially. So since we have this to be equal to this, we have this our tension to be equal to this. What else do I have to do now? Now you remember one thing now. This is for my first equation. Then another thing that you need to recall is this now. Coming to this area. Let's come to this area. When we come to this area, what are we going to have now? In this place, both of them are not equal. Now, why did I say that tension is equal to frictional force? Because the body is not moving. Nobody is pulling each other. They are just equal and opposite. But coming to this place, what are we going to have now? We're going to have it that your W is equal to weight. The weight of the body is still equal to, okay, your weight of your body is going to be what now? It's equal to your tension plus what again now? Plus what again? The weight of this body. Two things are acting on this body. the tension plus what again? Mass of the body and acceleration of the body. So two things are acting on this body. So which is the weight is being acted by the tension which is going up together with the mass of the body, which is m2, and the acceleration is going to have acceleration that is going to like the movement down. So that is why we have this. So for that reason, we can say that w minus t, if we take this to the next side, is still equal to what now? m2a. But your a, the body is not moving. This body is not moving. It's constant. So since it's constant, your a is equal to 0. So I have it as w minus t is equal to m2o, 0. So which is automatically 0. So I can say that w is equal to t. So that is my weight is equal to my tension. And since my weight is equal to my tension, what else can I say? That's my second weight. This is my second weight too. That's my second weight. My second weight is equal to my tension. So since my second weight is equal to my tension, I can easily equate everything. So what do I do? What do I do now? Since it's equal to my tension, what is it going to be now? Since my weight is equal to my tension, what am I going to have? It's still going to be m2g. Remember I told you, I just wanted to confirm. This thing I did here is to confirm if our weight, this our second weight, is equal to this our tension. And remember that this weight is equal to m2g. I've already stated it initially. So for this, sorry. So since that my second weight is equal to my tension, it's still equal to what? m2g. What am I going to do now? I can now say that my tension is equal to m2g. So you now equate it with this one. This is my equation 2. You can now equate it with this first one. I have it that t is equal to m1g and t is equal to m2g. So I can say that this is m1g is equal to m2g. Divide both sides by m1g. Divide both sides by m1g. Cancel, cancel. What do you have now? Cancel this, cancel this. The constant that we have is going to be what? m2 over what? m1. So the correct option to this question, let's look at the options. Let's look at the option. Okay. So the correct option to this question is option C. So the correct option to this question is option C. So the answer to this question is option C, which is m2 over m1. And that is exactly what we got. So that is it. All right, let's look at the next question. The next question says, okay, somebody say she did not understand this body. Since this body is yet to slide, this body is yet to slide. According to the question, they say in the diagram above, the hanging mass m2, this is our m2, this is our m2, is adjusted until my is on the verge of sliding. So m1 is here to slide, so but it's on the verge of sliding. And we are now asked to calculate the coefficient of the static friction. And coefficient of static friction, what do they mean by coefficient of static friction? Coefficient of static friction just mean, let me clean up this so that we understand what we mean by that. So coefficient of static friction just simply means that this is what we call the coefficient of static friction. This is called coefficient of static what? Friction. So that is exactly what they want us to find. So this is what we are asked to get. And how do we get coefficient of static friction? Remember, before I talk about coefficient of static friction, I needed to understand one thing, which is what? Always remember that the word force is the same thing as your weight, and it's still the same thing as your tension. They have the same formula. Why did I say they are the same thing? They have the same formula, which is mg. All of them, they are the same thing. Force is their general name, but weight and tension, depending on the way they are acting, weight acts downward and tension acts in opposite direction to your weight. So if the weight is acting downward, your weight will act upward, like the way we are seeing here. Look at this diagram. Look at this way we are seeing here now. The weight is acting downward, the tension will be acting upward for this mass 2. So for our mass 2, what do we have now? We have the weight is acting, our WT is acting downward, and our tension is acting upward. But let's confirm if actually this our weight is equal to T. Let's confirm, because sometimes you might look at it that your weight and your tension may not be the same thing. Actually, weight is acting downward. Like I said, this weight is acting downward. I hope you guys can see where I am pointing out. Please, I hope you can see where I'm pointing at. I'm talking about this our W2. Okay, all right. So since this weight is acting downward now, the tension is acting upward. But we need to confirm if actually, if this weight is acting downward, your tension is acting upward. We need to confirm that. Let's confirm. I say let's confirm before we start solving. But before we confirm that, remember one thing. Look at this W2 that we have here. This is our W2 that we have here. This is our W2. It's going to comprise of two things, which is it's going to comprise of what you call your mass and your G. That is your this thing. So we can still say that this is going to be M2 and G. But before we continue, like I said, we need to confirm if our weight is equal to our tension. Let's confirm if this weight is actually equal to our tension. So we need to confirm that. That's what I want to do now. So how do we confirm? Now you recall one thing. What will you recall? Recall one thing. What will you recall? What you're going to recall is this now. The weight of that for our second mass, this is our second mass, this is our W2. The weight which is going down is being acted upon by the two things are acting upon it. Like two things are acting upon this weight. Now, what are the two things that are acting upon it? First of all, the force that is pulling it up, which is known as your tension, plus what again now? The elementary entity that it has. Two things are acting on the weight. Elementary entities that you have and the elementary entity that it has. Let's continue. Now, I say that this weight, this W2, this weight comprises of two things. The force that is pulling it up, which is known as your tension, and the elementary entity that it's being made up of, which is M2 times, normally it's supposed to be times acceleration. Acceleration meaning that if it is going up or going down. But since the body is static, it's not going up or going down. Now, our acceleration is equal to 0. So for that reason, we're going to have it as W2 is going to be what? T plus M2 bracket 0. It has no acceleration, so that is why I said 0. So for that reason, we have W2 is equals to what? W2 is equals to T automatically. That's what we have here. It's going to be T. So we have now proven that our W2 is equal to T is equal to what? Is equal to T. Like we've proven that our W2 is equal to T. And since our W2 is equal to T, like I told you before, it's still equal to what they call M2G. And why did I say M2G? M2 is the mass, that is the mass that it has. And G is the force of gravity that is pulling it down, which I've already stated initially. Now that is for the first one. So this is what for the first one. Then for the second one, which is under M1, for the M1, what do you have now? We are going to have it as your frictional force. Your frictional force is equals to frictional force. And what opposes the frictional force? Your tension. That tension that opposes this one. So if the frictional force is going this way, the tension is going in opposite direction. Remember that the tension is pulling it towards the direction, but the frictional force is keeping it away from sliding. So what do you have again now? Now, what is your frictional force? You remember that your frictional force has a formula. And what is the formula for your frictional force now? Your frictional force has a formula. What is the formula now? It's given if frictional force is given as what UR. Okay, so is given as UR. So what do we have here now? We are going to have it as what do you have as your UR now? I'll just say UR is equal to your tension. Your UR, okay, this is not UR, but the coefficient of static friction times your normal reaction is equal to your tension. Remember why I say this? The reason why I say this is because this frictional force is going in opposite direction to your tension. So what is your R now? Your R, which is your normal reaction, is going to be mass. I've said it before. Your R is going to be your mass times acceleration due to gravity. So I can say that my normal reaction is equal to my mass which is the first mass, times the acceleration. So this is going to be m1 times g. So I can just say this is going to be m1g is equal to tension. So this is for my one of the equation. Let's call this one equation 1 and let's call this one equation 2. So when you combine both equations, what do we have now? You can now agree with me that under my first equation, any of them can be a first equation. Even if you call this one first equation, what is going to be my first equation? Under the first equation, what do you have now? Your tension is equals to what? Your tension is equals to what? M2G. Okay, let's call it anyone. It's equal to, okay, the second one, let's say this second one, what do you have your tension? Your tension is going to be what now? M1G. So since we are looking for the coefficient of static friction, I'll divide both sides by M1G, cancel. The static friction, this one will cancel this one. So what do you have now? The static friction is going to be what now? M2 over what? M1. So that is it. I hope the explanation is very clear this time around. All right, nice. Okay, let's go over to the next. Let's quickly solve that question number 9. For question number 9, what do we have here now? Now we have the following. Bear it in mind that a machine requires 1000 joules. Now this is called work output. This one is called your work output. This one is called your work output. This is called your work output. And how did I know it's your work output? They say it requires. So what it requires, like the outcome, that's what I mean by it requires. So that's how I knew. So this word requires now made me to know that this is your work output. And they say that work output is 1000 joules. Remember that the unit of work is joules, so I won't bother myself with this. It's already joules. All right. Okay. So it requires, okay, of work to raise a load. And when you talk about load is always input. Load is always input. So that's it. And effort is always output. So that is it. So they said the load is how many? So for our work inputs, is going to be what now? Force times distance, which is the formula for work. And the force that we're having here is for the input. The force that we're going to have here is going to be load times what again now? Times your distance. Remember that one of the forms of force that we have is load. Load is also a form of force. So we can say this for load. So this load is a form of force. We have various forms of force. Apart from push, pull, drag, tension, load is also a form of force. Okay, so what do we do now? We'll now say that our load is 500 Newton. I'll say 500 times, and what is our distance? Our distance is 1.5. So when we multiply this now, what do we have now? Okay, so when we multiply it, it's going to give us what? 750 joules. So what formula do I use? I'll just say they say I should calculate the efficiency. I'll just say efficiency is equal to work outputs all about what inputs times 100 over 1. So what am I going to have here now? My output is already, I think I reversed it. Did I reverse it? Sorry, I think I reversed it. I made it. Let's proceed. So this is going to be what the correct form, the correct way to write it's going to be what's, okay, this is going to be what now? Work inputs all over work outputs times 100 over 1. So this is going to be 750 over what? 1000 times 100 over 1. So the correct answer is going to be what now? 75%. So the answer is going to be 75%. So that is it. And 75% is option B. All right. So now let's look at question number 10. Question number 10 says, in an experiment to determine Young's modulus. Young's modulus, okay. Several loads are attached to the wire and the corresponding extension measured. The tensile stress in each case depends on, so the tensile stress depends on, let's look at what tensile stress looks depends on. So we say that the tensile stress, question number 9, tensile stress depends on what? First of all, what is tensile stress? Tensile stress is given as what now? Force over area. Whereas tensile strain is given as extension over your length. So this is for your strain. So for your tensile stress, what do we have here now? We have it as what now? Force over what? Force over area. So what do we have under this now? Since it is force over area now, what exactly are we going to have now? Now this force now, we have it as force over area. So this tensile stress depends on what you call your force. It depends on area, and the formula for your area is going to be what? The stress. The force over area. Area is going to be pi r squared. So you see that the stress is dependent on the force, and the area, and what the formula for area is what? The radius. So it depends on the force, and it also depends on the radius of the wire. So the correct option is what? Option B. So what is option B? Remember I told you that this force is the same thing as your load. It can be your load. Then this your area automatically has a formula of pi r square, which is your radius. So that is why they say that it's going to be what? Load. It's going to be what now? Load and the radius of, so the correct option is this, load and the radius of the wire. See the way they ask you questions. The questions they always ask you are very, very simple, just for you, a matter of you to think correctly. So look at the next question. The next question, next question of number 11 says what? Okay, let's solve number 11 before we share, okay, wait, before we solve question number 11, let's share another link so that we won't be cut off. So let's share another link. Let me generate another link so that we join and we do. Okay, hold on. Okay. So can you guys still join? Can you guys join? Are we there? Can you join? Can you join? Okay. Oh, somebody have even solved number 11. Whoa. Oh, she did, baby. They get the power. She don't solve number 11. Sharp, sharp. Nice one. Okay. Well, look at it. the same set of people. Okay, let me enable your chat box. Okay, can you see my screen? So we have to leave the old one now. So let's end the former one and cough everyone. So are we active here? Can you all see my screen? Can you all see my screen? Can you all see my screen? Okay, okay, companies, users joined, okay. Okay, okay. That's very nice, that's very nice. Someone have already solved question number 11 for us in the other. That is, it'll be, suppose of, let's see how you solve it again. Let's look at the questions, how you solve it again. So if they solve, let's see the questions again, like your solution. Let's have your solution again here. Someone just automatically solve this question. But before then, there's something I need to understand under question number 11. Question number 11 is under what you call pressure. And you need to know one thing. Aside the formula that you know, that's pressure, what formula do you know as pressure? You know that pressure is given as force over area. You should also bear it in mind that pressure is the same thing as your density times height times your G. This is another formula for pressure. You should also know that. I'm not here to start proving how this one were gotten, because if I start proving it now, you might be confused. So I don't need to start stressing with how they call this. This thing is called density times height times your gravity. So the question says the figure above shows the height of two liquids X and Y. Two liquids. We have liquid Y, we have liquid X. Now, when some air is sucked out of the apparatus, okay? So you know that we're going to suck out air apart from both of them now. So we're going to use the same pressure for both of them, both X and Y. All right. They now say the diameter, is sucked out of the apparatus through pump P. Yes. The diameter of the tube X is twice that of the tube in Y. What is the relative density? Okay, the diameter. Remember, they say diameter. Now, I need you to remember one thing. I need you to take note of one thing. If you are given questions like this to solve, don't panic. The first thing you need to do is read, try to understand, and know what next to do. If you hear the word diameter, you know the word diameter. If you hear the word diameter, you need to know where this diameter belongs to. Oh, she even solved it very fast. Wow. Looks like the values that she did now. So they say that the diameter of the tube is of X is twice that of Y. What is the relative density of liquid X to that of Y? So how do you get that now? Remember what I told you. This is the formula. So now, because for X and Y, they are being pumped out through P, so they will have the same pressure. So which means pressure at X is going to be the same thing as pressure at Y. So that is the same thing. And what is the pressure now? Pressure, I told you the pressure has these formulas. It means density of X, height times your G. Height of X, that is the height of X times your G, is equals to density of Y times your height of Y times your G. So now you are asked to get what is the relative density of X with respect to liquid Y, X to Y. So we'll divide both sides by what? Now let's divide this side by the density of Y. Let's divide both sides by density of Y. So you cancel. Then you now divide both sides by density of X. Divide both sides by density, height of X. So what is our height of X? First of all, I didn't give you the height. The height of Y, please. Height of Y is 22.5 and the height of X is 7.5. So when I divide this now, what do I have now? Density of X to density of Y is going to be what now? Height of Y all over the height of X because when you cancel this G, cancel this G, what is remaining is this and this. So I have it as height of y all over height of x, and height of y is 22.5, all over height of x is what? 7.5. So when you divide both sides, it's going to give you 3, and that is why she said it. The option is option C is the correct option. Okay. All right. So who's going to solve question number 12? You see the same question. One thing about this exam body is that when they start asking one particular question, they'll continue with that question. So question number 12 has to do with the same under the family of density and so on. So how do we solve question number 12? So for question number 12, do we have an idea of how to solve question number 12 of density? So this question and the last question that we did has something to do with density. So if I'm to solve this question now, how will I solve this question? Okay, so I'll just say, I'll just quickly say, sorry, hold on. Okay, I'll just quickly say one thing. So I just said, what formula am I going to use? First of all, let's look at this question. The question says, if a sphere floats in water, and the density of water is what? What's the density of water? They say that the density of water is 1000. You know the formula for kilogram per meter cube. Remember the formula for density. What is the formula for density? What's the formula for density? The formula for density is what? The formula for density is what? Density is given as what? Mass over volume. That's the formula for density. Mass over volume. So now they say that the density of water, that's why you have it as kilogram per meter cube. Now they say that the density of water is 1000 kilogram per meter cube. That's the density of water. Okay, density of water. Okay, and with 0.5 of its volume submerged. So the volume of this water is going to be what? 1/2 submerged. So 1/2 submerged. So what again do we have, you know? So the volume is 0.5 submerged. In fact, let's just call it this way. The volume is 0.5 submerged. So let's put it, this 1/2 submerged is something as 0.5 W. So it's something that the volume of our water is just 0.5 W. So we don't need to stress much. Now, they now say that sorry, hold on please, let's accept this people. So they now said that, okay, that is for the water. I'm done with the water. I'm done with this water of your thing. I'm done with this water. They now say, and floats in oil. For oil, now this time I'm now in the oil section, and floats in oil with 0.5, and floats in oil with 0.5 of its volume. So for volume of oil, for oil, the volume is going to be what? 0.4 oil. That is the oil. The oil is going to be 0.4 oil. For water, it is 0.5 water. The volume is 0.5 water. For oil, the volume is 0.4 oil. Okay. Look at the way I'm interpreting this question. Then I now ask you, the density of oil is, then you are now looking for the density of oil. Density of oil. Very simple. Remember, let's go again. We have density of water. The density of water is how many? 1000 kilogram per meter cube. Please, if you do not understand what I explained, go to the chat box and let me know. I hope you guys are understanding. I don't need the audio. Just tell me if you don't understand. Tell me this. Reply in the okay. You don't understand in the chat box. Okay. Somebody say there are some of you that join. Go to the chat box. Stop raising hand. Go to the chat box. Look for chat box where to chat, and go to and drop your message, please. Okay. So who else doesn't understand? Okay. Chidebe said that she doesn't understand. Okay. Who else? So that I will know how to go about it. All right, let me explain. Let me interpret the question. Let me interpret the question again. I will reinterpret the question from the beginning again. So since we don't understand, I will start from the beginning to explain everything so that you understand what I'm saying. Okay. So, okay. Precious. Okay, I don't understand. All right. Okay. How about Chidera? Did you understand what we're doing? One, okay, don't understand. Okay, okay, we don't understand. All right, just give me a moment. Just give me a moment. Okay, just give me a moment. All right, now let me re-explain this. Let me re-explain this. Let me re-explain it. Let's re-explain. Okay, all right, all right, all right, all right, all right. Okay, so let's quickly look at this question. Let's look at this question. Now, whenever you're giving question like this question is very, very simple. In fact, any question they'll give to you in your JAMB, they are always very simple. So you don't need to. Yes, this is physics. For those of you that joined now, this is physics. So this question is very, very simple. So what you're going to do is, first of all, read the question. The question says, if a plastic sphere of a plastic sphere, remember that this sphere, the same plastic sphere, we have this sphere, it's going to have a particular mass. It's going to have mass. This sphere is going to have a mass. It must have a mass, okay? So let's call M as mass of the sphere, ms as the mass of the sphere. So this is called mass of the sphere. Let's call it mass of the sphere, sorry, sphere. This way. What's happened? What just happened? Now, why is my network leaving? Sorry guys. Oh god, why is my network going out? Can you all see my screen? Please, my network went off again. Can you all see my screen? Can you see my screen? I don't understand why this network have to be a problem this night. You guys can see my screen, right? Okay, so for this now, what will I say? I'll just say, did you remember? Let's change my Bible. Okay, did you remember that density, the formula for density is what? Mass over volume. This is the formula for density. So when you cross multiply now, I can now say that my mass is equal to my density times my volume. This is the formula that I'm going to have. So since I have this formula now, what else am I going to do now? I can use this formula to solve this question. Why will I use it to solve this question? Remember, they say that the same sphere that we have here, we have to put this sphere in water and that same sphere in oil. So that same sphere was put in water and that same sphere was put in oil. So which means that it's going to still be the same mass. So since we have it now, we can say that it is the same mass of the sphere that was put in oil. If we put it in oil, we are going to have the formula as density times volume. Why am I using this formula? The same mass, we have it this way, which means that, let me put it this way. Since it's the same mass that we have now, the same mass of sphere that we use now, the mass of that sphere will be same in water, and the mass will also be the same in what? In oil. Mass of that sphere, since we did not change our mass, the mass of that sphere will be the same in water and the mass is going to be the same in oil. So since the mass is going to be the same in water and mass is going to be the same in oil, what will I say? You will now say that the mass of that sphere in water is going to be what? Use this formula, apply this formula. You now say density of water times volume of water. How about mass in oil? It's going to be what? Density of oil times volume of oil. So that is it. So for that reason, what am I going to have here now? I'll just say density of water times volume of water is equal to density of oil times volume of oil. Remember, this is, you know how I got this. Remember, this is how I did it. And likewise, this one, you know how I got this. So this is how I did it. That is how I did it. All right. So let's proceed. So what will I say now? What is the density of water? The density of water, we're looking for density of oil. So I will now say divide both sides by the volume of oil. Divide both sides by the volume of oil. You cancel. What do you have now? The density of oil is going to be what? Density of water times volume of water all over volume of oil. So which is equal to, what is the density of water? The density of water is going to be what? The density of water is going to be what? 1000 times the volume of water, remember, is 0.5 all over 0.4. So when you multiply, when you do your calculation and you multiply, what else am I going to have as my answer now? Okay, so I'll automatically have density of water is going to be 1000 times 0.5 divided by 0.4. So this is going to give me what now? 1250. So which is option what? Option C is the correct option. So a quick rundown. I know they see your screen. Leave this. Okay. Let me explain again. Now, coming to this now, if you are to solve this question, first of all, I believe you guys understood how I got all these values now. First of all, let me run down again now. They said if a plastic sphere simply means that this sphere has a mass. So ms, let's call ms as the mass of the sphere. Okay, they say it flows in water. And the density of that water, the density of water is 1000 kilogram per meter cube. That is the density of water. And with 0.5 of its volume submerged. So the volume of that sphere in water is 0.5. So that is it. Then they now say that it floats in oil. Another one is oil. It now floats in oil. Okay, in oil. With 0.5 of its volume. So the volume of that mass in oil is 0.4. They now said you should calculate the density of the oil. That is exactly what you want to calculate. Now say that, did you remember the formula for density? The density is given as mass over volume. That is the formula for density, mass over volume, whereby if you cross multiply, we have it as mass is equals to density times what? Your volume. Now, what we did was that we've gotten your mass is equals to density times your volume. Now said, because we use the same sphere in water and we also use it in oil, the mass of that sphere, ms, will be the same thing in water. The mass will be the same thing in water, and the mass will also be the same thing in oil because it's still the same sphere. And I now said that the mass of the sphere in water, which is mw, is equal to, what's the formula for mass? The formula for mass is going to be density times volume. So, but here I'm going to say density of water times the volume of your water. So that is exactly what I'm going to say. Then for the oil, I'm going to say that for the oil part, MO, for the MO is going to be density times volume. But here I'm going to say density of oil times the volume of oil. And since both of them are the same thing, I can equate them. I can equate these two together. So if you equate these two together, I'm going to have it as density times volume of water. You know, mass of water is the same thing as this. So it's still equal to what? Density of oil times volume of oil. So what we are going to do now is we are going to say make density of oil the subject. So we say density of oil divided by the density of oil. So when you cancel this, what do you have here now? The volume of oil is equal to, what is the density of water? The density of water is 1000 times, you have it as 1000 here. Look at it here. The density of water is 1000. I've written it out. Then what is the volume of water? The volume of water is 0.5. So I'm going to write it here, times 0.5 all over what? Oh, sorry. What am I even calculating, Seth? Oh, sorry, guys. Please forgive me. I'm supposed to calculate the density of, what am I even calculating? I'm supposed to say VO divided by VO. So I'm calculating for the density of oil. So density of oil is going to be what now? Density of water times volume of water all over volume of oil. So which is equal to, density of water is 1000 according to what we have here. Volume of water is 0.5 all over volume of oil. Volume of oil is 0.4. So when you calculate all of them, it's going to give you 1250 kilogram per meter cube. So that is your final answer. So the answer to this question is option C, which is the correct option for it now. All right, now let's look at question number 13. Who can solve question number 13? who can solve number 13? So they will ask in your JAMB physics. It's very, very simple. Very, very simple. They are not difficult at all. So let's look at question number 13 altogether. So let's say question number 13 says a platinum resistant thermometer wire has a resistance of 5 ohms at 0 degrees Celsius. So I will sketch this. So I'm going to have this. You know how it's been sketched. I have this. So they say that a platinum resistant thermometer wire has a resistance of 5 ohms. 5 ohms. Let's call here 5 ohms. Then at 0 degrees Celsius, here is 0 degrees Celsius. Okay. Then what again now? Then 5.5 ohms at 100 degrees Celsius. Here is 5.5. Then here is what? 100 degrees Celsius. Okay. They now say calculate the temperature of the wire, which can be anywhere here, T. When the resistance is 5.2, here is going to be 5.2. You see, that's all. You don't need to, there's nothing much remaining. And you know how to calculate this. How to calculate this is going to be 100 minus 0. You can say, or you can even say T minus 0. You can say T minus 0. I started from here first. So I say T minus 0 all over 100 minus 0. It's still the same thing as what? Since I say T minus 0 first, I'm going to say 5.2 minus 5 first all over 5.5. 5.5 minus 5. 5.5 minus 5. The other way around, you can also do it the other way around. They're all the same thing. You can also do it the other way around. So what's the other way around? Can you do it now? You can also try something. You can also say 100 minus 0 all over T minus 0 is still the same thing. So you can reverse this in. You can turn it upside. It's still the same answer. So T minus 0 will give me what now? T all over 100 minus 0 will give me what? 100 is equals 5.2 minus 5.2 minus 5.5 will give me what? Will give me 0.2. So this one is going to give me 0.2 all over 5.5 minus this will give me 0.5. So I'll cross multiply. If I cross multiply, what do I have now? I'm going to have it as 100 times 0.2, this to this, all over 0.5 is going to give me my T. So what is going to give me my T? My T is going to be what now? If you multiply and divide, it's going to give me 40 degrees Celsius, and that's all. So the answer to this question is option C. Option C is the correct answer. That's all. So that's it. All right. So now next question says, what's the next question? Question number 14. Can any of you solve question number 14? Can any of you solve question number 14? Question number 14 falls under the question under what they call linear expansivity. I've done a video under linear expansivity. So if you are yet to watch the video, please check my YouTube channel and see where I did question. I did something under linear expansivity and learn. So I've done, in fact, basically I've done some of the videos that's this question and like the questions that you normally see in your JAMB. So let's look at question number 14. So for question number 14, what do I have here now? For question number 14, let's look at question number 14. 14 says, let's look at question number 14. A bridge made of steel, okay, 600 meters. So the length of that steel is 600 meter long. They even say it's 600 meter long. Okay, now what is the daily variation in its length? Daily variation in its length means change in length, and change in length simply means our extension in length. Like change in length, like we're going to have extension in length, or you can say change in length. If you don't want to, I'll just say change in length. It's still okay, but I can still use it to represent that now. So we are asked to get our change in length. We don't know what our change in length is. What is the daily variation? So that daily variation in length is the same thing as change in length. If the midnight time and daytime temperature are 100 degrees Celsius, so our theta 1 is 10 degrees Celsius, sorry. Then our theta 2 is 35 degrees Celsius. Then change in temperature. Our change in temperature change in temperature. Our change in temperature will be what? Will be what? 35 minus 10, so which is equal to 25 degrees Celsius. So then they also gave me what they call linear expansivity. So what will I say? I'll just say linear expansivity is equal to your change in length all over your original length times your change in temperature. Let's quickly solve this now. So what is our change in length? That is what we are looking for. What is our change in temperature? We have change in temperature. What is our original length? We have our original length. And what is our linear expansivity? Our linear expansivity for this question is 0.000012. That is our linear expansivity. So cross multiply, you will now say our change in length is equal to your linear expansivity times your length times your change in temperature. So what is your linear expansivity? 0.000012. That is your linear expansivity. It was given to you in the question. All right, times what is your length? Your length is how many? Your original length is how many? 600 times what is your change in temperature? 25 degrees Celsius. The question is, why did you change that 25 degrees Celsius to, why did you change it 25 degrees Celsius to meter? I don't need to. This is a practical question. So we don't, this is not gas laws that where you do your change in temperature to Kelvin, chemical. So here I don't really need to do such a thing here. So what I have here is this now. By the time I multiply 0.012 times this, I multiply everything. So what's going to be my final answer now? My final answer is going to be what now? I'm going to have it as 18 cm as my final answer. So the change in length is going to be what? 18 cm, which is option C. So that is it. All right, let's look at question number 15C. All right, now let's look at question number 15. One of the most important application of bimetallic strip. Bimetallic strip is a kind of strip that uses two metals. One of them will be able to expand very well than the other. So it uses, one will be able to expand very well, like one will be able to, like we have, this is the first metal, and this is the first metal, and this is another metal on top of that first metal. So that first metal, the second metal will expand more than the first metal. So where do we use such metal? We use it where we need a kind of contact, break and contact. So probably when you hit the metal will now bend and make a contact. When it cools, the metal will now return to its normal position. So where exactly do we need it now? We need it at a place called thermostat. There are thermostats that you use in your pressing iron. When the iron becomes too hot, it will automatically switch off itself. So we don't use it in altimeter, which has to do with height. We don't use it in thermocouple, which has to do with heating of metal to generate electricity or something like that. We don't use it in hygrometer. So it's only in thermostat where you can now make and break a switch. So that is it. So quickly, question number 16 says that at constant pressure, the density of a fixed mass of a gas is what? Okay, let's look at constant pressure. First of all, according to this now, at constant pressure, according to Boyle's law, it is inversely proportional to your volume, and according to Charles' law, your volume is directly proportional to your temperature. So your volume is directly proportional to your temperature. So for this question, I think this question is going to be the last question I'm going to take here. So for this question now, you have to remember one thing. What X are you going to remember now? You have to remember that I told you that density is given as mass over volume. So which means that your density is inversely proportional to your volume. So which means if this is going to be your volume is inversely proportional to your what? To your density. So for this now, I can say that since my pressure is inversely proportional to my volume, I can also say that my try to check something now. Since I say that now, did you know I can also So since I have it now, I can say that my density, I have it that my density is inversely proportional to my volume. In fact, just bear it in mind that your pressure is inversely proportional. Your pressure is inversely proportional to your density, and also your temperature is inversely proportional to your density. So just bear it in mind that way. So for this question, the correct option is going to be, we're going to have it as, let's look at it here because I think it didn't come out here. So let's look at it. We have it as option C, so which is inversely proportional to its temperature. So your density which should be is inversely proportional to your temperature. So that's what we have. You can say that this is inversely proportional to your temperature. All right, question number 17. Question number 17 says, how much heat is absorbed? This is under heat capacity. Heat is absorbed. You know, the formula for heat, we have various formula for heat. So, but because they mentioned mass, they mentioned specific capacity. So I will now say that the formula is going to be mc theta. Assuming they mention something like latent heat, I'll just say that the formula is going to be ml. Assuming they mention something like current and voltage, I'll say IVT. So it depends on what they mentioned. So because they mentioned mass and specific capacity, so what will I do now? I'll use MC theta. They said how much heat is absorbed. Okay, how much heat is absorbed? We're looking for heat. When a mass, we're given mass, we're given the specific capacity as this, and we're given the temperature change as this. So what do we have now? What is our mass? Our mass is equal to 0.05 according to the question. The specific capacity is 390 joule per kilogram per Kelvin, and so on. Yes, per Kelvin, yes. Then we are also given temperature change, which is equal to what? 20 and 70. So I'll say 70 degree minus 20 degrees Celsius. So when I subtract both, I'm going to get 50 degrees Celsius. So the formula is going to be H is equal to, my mass is 0.05 times my C is what? 390 times 50. So when I multiply everything together, what am I going to have? My final answer is going to be what now? 9.75 times 10 to the power 2 joules. So that is exactly what I have. So which is what? Option B is the correct option. All right. So then question number 18 says that a block of ice floats in water. Okay. A block of ice floats in water. Quickly, let me answer question number 18 before we end this call. So they said a block of ice floats in water. When you have a block, this obeys Archimedes principle. So when you have, this is your water, and you have your water, and you drop your block of ice on it now, this your block of ice will now displace some amount of water. Look at it now. We have water, and this is filled up. If you drop your ice in it, it will displace some, that volume that this ice occupied will now displace some water out of it. So what happened now? What will happen now? They say that a block of ice floats on water inside a container. If the block of the ice gets melted, the level of the water in the container will do what? The level of the water in the container will remain the same. It will not increase. Why? Because that ice removed, when you drop that ice initially, it removed some volume of water which the ice used to occupy the space. So when it melts now, that ice will now occupy that amount of volume of water that it displaced. So it will now occupy, so it will now make that water to remain the same. It will not increase, it will not decrease. So the correct option is option B. So that is it. All right, now I think we have question number 19 and 20. Next time we continue from number 19 because of our time. So we are going to stop it here. So I hope if you enjoy these things, if you enjoy this thing that we're doing, don't forget, if you're yet to subscribe to my YouTube channel, just make sure that you subscribe, and don't forget to click on the notification bell icon to know when I upload a new video. So